It's about flexibility, efficiency, and low capex, because these solutions offer a reasonable capex amount for good flexibility solutions. So we start from the fact that in the oil and gas industry, very often pumps and compressor cannot be run at a fixed point, but some flexibility is needed. Now, how can we achieve this variation in the output of pumps and compressor? We start here with the example of a pump, but similar consideration apply to all centrifugal machines, which means also centrifugal compressor and centrifugal fans. So this is the typical head versus flow rate characteristic curve of a pump. This is a possible resistance curve of a plant. So the operating point will be given by the intersection of the pump available head versus flow rate against the resistance of the plant. Yeah. Now, if we want to reduce, for instance, the output of the pump to have a smaller flow rate, we have two possibilities. One possibility is to act on the plant characteristic, which means we make it steeper, for instance, throttling. Yeah. And if we do it, the operating point moves from the right to the back, and the new operating point is the one which you see here. Another way to achieve this is to act on the speed of the pump or of the compressor. And if we reduce the speed of the pump, the new characteristic will look like this, depending on the speed value, until we find the new intersection between the plant resistance and the available head, which meets the flow rate requirement. So the first difference we see in this is the difference in the head which the pump has to overcome in case A and case B. So as the power the pump needs is basically proportional to head times flow, the power needed by the pump in the first case when throttling is this one. The power needed by the pump reducing the speed is this one. So there is a very important saving in energy. But you are all very expert in turbo machinery, so one thing which is clear to everyone is that this was the rated point of the pump. The design of the pump was optimized on best efficiency in this area. So now, if we throttle and we move the operating point to this area, we move away from the best efficiency area of the pump. So this has also to be kept into account. Whereas if we reduce the speed of the pump or the compressor, the best efficiency area moves together with the reduction of the speed. So here we are still in the area of the best efficiency of the pump or the compressor. There are many reasons. For instance, talking about pumps, if we reduce the speed, we also move away from cavitation problems. And if we talk about compressor, moving to the left can be moving close to the surge line, and reducing the speed can be staying away from the danger of the surge line. So let's have a general look at the most established driving system of which are used in the oil and gas industry. We see the fixed speed electrical motor plus gear, gas turbine plus gear, steam turbine plus gear, variable frequency drive plus variable speed electrical motor plus gear, fixed speed electrical motor plus VOITH.